This episode has its ups and downs. I'm gonna rock some cradles, I'm gonna walk some dogs, and dive into the science of the yo-yo. When we first decided to do the yo-yo, I wasn't even sure whether there was enough science to talk about, but I was very, very wrong. There is so much physics inside these things, and my research took me all around the world, and even into space. The yo-yo, it is one of the oldest toys ever, but we're still not entirely sure where it came from. Some people think ancient China or Greece or the Philippines, but what we do know is that it's thousands of years old. This is a picture of a kid playing with a yo-yo 2,500 years ago, which is wild. Some people think it actually originated as a weapon, a rock attached to some string. You could ditch it at your prey and then your weapon came back to you, which, yeah, I guess would be useful. Time warped to the 17th century, and by the time the yo-yo rolled into France, that's where it really took off. These days there are a couple of different types of yo-yos, but the concept is essentially the same. You got two halves or discs. These are called wheels, an axle in the middle, string wrapped around, attached to your finger, in a slip knot.
The slip knot.
But how does this classic toy relate to space exploration? Time to do some physics to find that out. All right, let's wind up this yo-yo. As we do so, it's storing potential energy in the string. Letting it go, gravity acts upon it, turning that potential energy into kinetic energy or movement energy. As it's now moving, that means the yo-yo actually has momentum. It's actually got two kinds of momentum. It's got the linear momentum of it going up and down, as well as the angular momentum of it spinning or rotating. Remember that, the angular momentum is super important for a yo-yo. So how does it spin? Well, the string is attached really loosely around the axle, allowing it to remain spinning at the bottom. This is called sleeping. As the yo-yo sleeps, friction between the string and the axle will eventually cause it to come to a stop, but a quick tug back up on the string adds more friction and energy, allowing it to climb back up again. All right, let's talk about inertia. Inertia is when things that are moving like to keep moving, like when you jump off a swing. It also means that things that aren't moving kind of like to stay put. Do I have to get up? Ugh. A spinning thing likes to keep its momentum even if forces are trying to stop it, which is called gyroscopic stability. And you can see that with this bike wheel. As I spin it, if I tilt this, it's resisting the change in direction so much that it actually moves me in the opposite direction. That's exactly what's happening in the yo-yo. Its gyroscopic stability is what allows you to do so many cool tricks with the yo-yo. Well, like some people can do cool tricks with the yo-yo. This gyroscopic stability is what allows the International Space Station to orbit smoothly around Earth. The ISS actually has 4 gyroscopes on board, which engineers use to control its orientation without the need for fuel. Just like a yo-yo, no batteries required. But can you even yo-yo in space? Well, turns out you can, but it's pretty tricky. In space, there's very little gravity to pull the yo-yo down, so it can't sleep at the end of the string. It just floats back up again. You've actually got to throw it down for the yo-yo to come back up. Now, astronauts have actually created their own yo-yo tricks that only work in the microgravity of space. So spinning things love to keep spinning, but how do you stop a spinning thing and how do you do that in space? Well, engineers have a trick they use to slow down spinning satellites, inspired by the yo-yo. It's called the yo-yo despin mechanism, which is exactly what it sounds like. By releasing weighted cables like yo-yo strings, engineers are able to stabilize rockets and satellites for precise moves in orbit, which is the same as sitting on a spinning chair and putting your arms out to slow down. So the yo-yo isn't just one of the oldest toys ever. It's a lesson in physics, a science experiment, and even an inspiration for space technology. Not bad for a bit of plastic and string. With all that in mind, I actually created my own yo-yo science experiment using some pot lids, some bolts and some rope, and now I have a giant yo-yo. But before I break something, please hit that bell and subscribe so we can keep talking about the amazing science of toys. I'll see you next time. Bye! Hey! It works. Oh, before we go, we put a bunch of references to yo-yo tricks in this episode. See how many you counted. Chuck it in the comments. See ya!